Hi, my name is Andrew McLaren, and I'm going to help you understand how to use density and stacking of atoms to relate these different parts of the problems. This problem's already been worked through. I have these notes were from a student that I was tutoring. In the context of this problem, I do want to point out that you probably want to convert to centimeters first before doing the volume conversions, because it's easier to go from like angstroms to picometers to centimeters, just a linear relationship, and then to plug that in as an edge length, as opposed to going from like cubic angstroms to cubic centimeters. Like you can do that, but it's just very messy. The main point, though, that I want to go over in this video is that when we're talking about density, you're going to need to be using the volume formula that's relating the area of one of these cubes. So this is considering the volume that contains two atoms. So you can't just get like a mass that they're talking about um, in a density formula and relate that to like a single atom just by itself. We have to consider this empty space between them. So like the density of this is considering that stacking, and if we're using these edges to find the volume of that space, that's not the volume of like a single atom, it's the volume of one of these cubes. And as a result, we need to be considering that the amount of weight in that volume is corresponding to, in this case, two atoms, because we had a um, body-centric cubic pattern. So there's about two atoms in a body-centric cubic pattern. So if we have the volume that's appropriate for this stacking, you need to consider there to be weight that's corresponding to two different atoms there. Um, so that if you were to then look at a single atom, that has half as much mass. And then if you think about that, that's the amount of weight per atom. And you can use this to then say, well, how much would a mole weigh? And that's going to be your atomic mass. So we can scale this stuff appropriately, but just be careful because the volume that you're using here is for this stacking. It's not like just using the volume of a sphere with the mass of a single sphere, because we need to account for this empty space in this type of problem.